Okay, the last video we talked about kind of the beginning of systems, intro to systems, and a few things that we need to be able to do in order to solve systems. Now, we didn't actually solve any systems. We just talked about the things that we need to know. And we're going to continue that by the graphing linear equations. So I'm going to keep this video short because I just want to stick to the graphing linear equations on this one. And then the next video we'll talk about a method of solving systems. Other than graphing. So what we're going to do is just practice graphing lines, a skill that we really need to be able to do when trying to solve systems. So y equals 2x minus 3. Now, every single one of these equations that I have made is set up in y equals mx plus b form, which is the slope-intercept form. Now, it's called slope-intercept form for a very, very good reason. The m value, m represents a number in the equation. Whatever number is there for m, right? The number that's associated with the x, the coefficient for x, that number is the slope of our line. And the b value, the plus b, so whatever number represents that, whatever constant we have being added or subtracted at the end, that value is our y-intercept. So essentially that's where the graph will cross the y-axis is at that number. So all of these equations are already in that form. So looking at A, we have y equals 2x minus 3. In that format, we can see that 2 is our m, therefore it's our slope, and minus 3 is our y-intercept, our b value, our mx plus b. So what we do is we always start on the y-axis. We start on the y-axis as our initial point, our starting point. Now, because we could see in the equation the y-intercept is -3, that's telling me that I'm going to go ahead and put a point at -3. I know that this line will cross through -3 on the y-axis. I don't necessarily know which direction yet, but I do know it's going through that one point. Now, we use the slope to determine where the rest of this line is going. It's sort of our roadmap, right? -3 is our starting point, and our slope 2 is sort of our directions, telling us where to go. Now, if the slope is 2, you really want to think of slope as a fraction, because you want to think of it as rise over run, because this tells you how high to go up or down and how far to go over, left or right. So when we just have the number 2, it's not a fraction, it doesn't show us as a rise over run. So we have to think of it as a fraction. The number 2 is the same as 2 over 1. Okay, 2 divided by 1 would still be the same thing as 2. So any whole number, essentially, you can just put it over 1 and make it look like a fraction. So if you had the slope of 7, you can put it as 7 over 1 and make it look like a fraction. That way you can really clearly see that 2 in this case is our rise and run is 1. So this is moving up 2, rising 2. So we would go up 1, 2, and then we would run 1, and we're running to the right. So we're going 1 to the right. So right here is where our next point would be. It's up 2 and then over 1. So I continue to follow those directions from point to point. So from that point, I would go up 2 and over 1 again. And I would have a point here. And I would just keep that pattern going, up 2 over 1, up 2 over 1, up 2 over 1, and so on and so forth. Now I'm going to leave my little roadmap, but leave the points. And of course, that's only filling in the right-hand side. We can go to the left-hand side too, but we just kind of have to work it backwards, right? It's still a line. We got to keep the pattern going. So if we go down 2 and right 1, or you can go right 1, down 2, however you want to think of it, just keep the pattern consistent, And there is your line for 2x minus 3. That's A right there. So now we're going to look at another one. We can look at B. B, we have y equals x plus 1. So this is in mx plus b form, mx plus b. But the m is invisible. It's just 1x. But that doesn't mean the slope doesn't exist. Doesn't mean that the slope is 0. It's 1x. So therefore, the slope is 1. Okay, but 1 is just a number again. It's helpful to think of slope as a fraction so I can think rise over run. So because 1 is a whole number, I'll just put it over 1, and now it looks like a fraction. It's still the same number, but now it looks like a fraction. So this tells me that I need to rise 1, and I need to run 1. Okay, but before I do that, I got to start with my y-intercept. My y-intercept, my b value, is 1. So let me pick a different color here. Well, let me actually do this in orange, so remember that one was orange. Let's pick purple. Okay, so our y-intercept is at +1, so I know that my line will start at +1. Remember, on the y-axis. The y-axis is here down the center. So +1 is right there. And now I need to follow my roadmap. My slope was rising 1 and running 1. So I would go up 1 and then run to the right 1. And it'd be right here. Up 1 and right 1. And I would just continue to follow this pattern throughout. Oops, I'm deleting my little lines. But rising 1 and running 1. So up 1 square and right 1 square. So that's the right side, but I can continue to do the same thing if I follow it onto the left side as well. I just got to go the opposite way, right? Down 1 and left 1, complete opposite. I can still get all these points. And you can see that there's your line for y equals x plus 1. That is for B. C, let's pick a different color. Let's see here. C, let's pick blue. C is just y equals 2/3 x. Y equals 2/3 x. Now the 2/3 is next to x. That's our m value. That's our slope value. But there is no plus b here. There's plus nothing, right? So there is no b value. But as you just see, I kind of wrote the b value. I'm adding nothing. So that means that my b value is at 0. Okay, so if the b value is not there, if that y-intercept is not shown in the equation, that's because the y-intercept is at 0. So we're going to put our first point right at 0 on our y-axis. And now we follow the slope. We follow the roadmap. So 2 is our rise, and 3 is our run. So from 0, we're going to go up 2, and then right 3. 1, 2, 3. And we go right here. And we continue doing that. We go up 2 and right 3. Continue going up 2 and right 3. Plot point after point. And then we go backwards as well on the other side. We go down 2 and left 3. Down 2 and left 3. Down 2 and left 3. And I'll go ahead and draw it all in. That's line C. Okay, let's look at the fourth one. Let's pick like a green or something here. Yeah, this is good. The fourth one, we have y equals x over 2 minus 2. Now, remember, it is 1x over 2. So if it helps you to write that in, write it in, because that helps me think that of the slope. It helps me see the slope. The slope is 1/2 because it's 1/2 x, or 1x over 2. Same thing. Our slope is 1/2, meaning we're going to rise 1, we're going to run 2. And our plus b, in this case minus b, our b value, our y-intercept value is -2. So our first point is at -2 on the y-axis right here. And now we follow the roadmap. We rise 1 and run 2. So go count up 1 and right 2, up 1 and right 2, up 1, right 2, up 1, right 2, and up 1, right 2, and so forth, so on and so forth. Continue to go backwards, do the opposite thing. Down 1, left 2, down 1, left 2, down 1, left 2, and there we go. So there is D. Okay. So hopefully we're starting to kind of see the pattern here. Hopefully we kind of get an idea of what's going on. Let's do one in red. Haven't done one in red yet. Okay, we did one in orange, but not red. Here we go. So we have y equals -3x plus 9. So there's my m is negative 3, and there's my b is 9. So I know my first point is going to be at 9. But now what about my slope? My slope's negative 3. But again, that's just a whole number. Well, it's not a whole number, but it's not a fraction, right? We need to look at it like it's a fraction. So negative 3, we just put negative 3 over 1, and now it looks like a fraction. We do that with any regular number. Just put it over 1, make it look like a fraction. So that means rise is negative 3 and run is 1. So if my rise is negative, then we're actually, instead of going up, we're going to go down 3 to start. So we're going to go down 3, count 1, 2, 3 down, and then run to the right 1. You always run to the right. I always go to the right. My first move is either up or down, but my second move is always to the right, whether it's positive or negative. I always will do it that way. That way I don't confuse myself. Because if you go down 3, but then you go left 1, you're making a positive line. That wouldn't work. So it is down 3 and right 1. Okay, a positive 1 at the bottom means to the right direction. So continue following that pattern from point to point. Go down 3 and right 1, down 3 and right 1, and we're going to just keep going and fill it in. All right, and now I can't really do anything on the left-hand side because there's not really room up here at the top to go up 3 and left 1. So my line is pretty much as full as it can be. That's E. And then we have one more that we can get a graph. One more, let's use, what color have we not used? We can just use like black, Never really use black. All right. So we have y equals negative 4/3 x minus 6. Okay. So our m clearly negative 4/3 and b clearly negative 6. So we're going to start. Our first point is going to be at negative 6. Now our slope negative 4/3. So I'm going to attach that negative to the 4 as my rise part and leave the 3 at the bottom of positive 3. Okay. Only one of these numbers needs to be negative. I always put it on the rise portion, which really means we're going down. Okay. Because if it's a negative rise, it means we're going to go down. So we're at negative 6 right now, but we need to go down 4 and right 3. So 1, 2, 3, 4, and right 3 right here. Now, I don't really have any more room down there, so I have to go backwards now, do the opposite thing, go up 4 and left 3, up 4, 1, 2, 3, 4, and left 3, up 4 and left 3. Okay, and there is my line. So that is line F. All right, that's how we graph our lines. So every one of these needs to be in slope-intercept form. So if you look back what we did in yesterday's video, we rearranged all these different equations so that all these equations were in mx plus b form. Obviously, it's super helpful because then once they're in that form, we can graph each of them using the method that we just did. Plotting the point on the y-axis first. So remember, these points right here on the y-axis were the ones we plotted first every single time. And then we just used our roadmap to get the direction of the line from whatever the slope was. Okay, so please be very, very careful about that. Be very, very aware of all of that. All right, that'll be it for this one. I'll see you guys in the next one later.